All right. Well, happy Thursday. Um, we're about done, believe it or not. This is crazy. The plan here is to wrap up the demo today, do a little chat program here. Um, I want to try and get it working with a graphical user interface for you so you can see how that works with that as well. Um, we'll see. I've got something that I think works. It should be a lot of fun. We'll see. We'll see how well that goes. Then we got Thanksgiving break. Take the week off, work a couple days, whatever you got to do here, that's fine. 12.4, I don't have plans to meet. This idea here is your team can finalize, finish up whatever they need to do, work on your last couple tasks, or figure out what you're going to do for the final week of finals to actually get this thing across the finish line. Again, if you're done on 12.4, fantastic. If you need some more days, that's okay. You guys can figure it out, however you want to break that work up here. And then on our final exam slot, we're going to do presentations instead of an exam because, again, I think exams are stupid. And I would hopefully it'll be a lot of fun. You can see what everyone else did, see how they made it. We can ask a couple questions here and there. It usually takes 5 minutes tops. You know, if you really like to talk a lot and you want to show something you thought was really cool, maybe it'll go 10 minutes for your group. I don't think it'll go that long. So we get through relatively quickly here, but notice it is a slightly later start here. So it's 6:30 p.m., not a 6 p.m. start. So, because you might have other finals the way they do their slots here. So hopefully that'll go pretty well for you. Um, yeah, and then you wanted to do a quick review. Let me pull up IntelliJ here. Over what we're working on before. Does someone else want to try and run the client on your laptop and connect to my server instead of just me having it doing it locally? If you pull the code down for this networking project and run the client code. So this was the server code, and we had the separate project was the client code. Let's see, which one was that one? Look at my recent list. Right, it was the Echo client that we stole from the book example. So if you want to go grab that one here, that was on my GitHub. F296. So it's probably easiest if you just clone the repository and you can go grab the. Did I not commit it? Did I forget to commit? Guys. Seriously? I did? Oh my goodness. Yep, I didn't commit any of that. Oh man. Okay. Sure. That's sorry about that. All right. It also has the registration stuff. I really thought I committed that for you too. I'm sorry. Someone's got to yell at me when I do dumb things because it's on my computer. I had it. All right, so it should be out there now. If you want to go check the repository, get the Echo client, you should be able to run that. So I'll run the server code here. Yeah, yep. We're going to have to change the address. So instead of connecting to localhost, we'll put in my address of the Echo client. Give me just a second. I gotta go find what that one was here again. Oh, there should be a whole project there. Right? There's a whole in the Echo client. You can just open the project itself as a IntelliJ project, and then you should be able to go run it. Again, you just got to change the address here. So localhost isn't going to work. We'll try and connect to your computer here. So when I run the server, we just need to run get my IP address. We'll try it and see. Come on. Oh, helps if I can spell right. So this address should hopefully connect if you plug this one instead of localhost. So 141.215.203.78. So for the Echo client? Yep. Yeah, so if you open up the Echo client project. Yep, and go to the main Java. We're going to find that line that has, instead of localhost, we're going to put in IP address. That'll be a lot more fun. Yeah, so like the socket one? Yeah, line 19. So just change that for 141.215.203.78. .203.78. Didn't connect, and I screwed up on my side. That address. I need to do mine here. This one's running, but it's running looking for localhost. Name. Oh, it might not have the Java configuration then. So I need to set the Java config for it. Okay, yeah, now it wants to work on the network. Awesome. So occasionally you might get the prompt from Windows Security. Mac probably have their own sort of prompt here. Saying, are you sure you want to open this on the network? Yes, I want this to have network access here. That's a good sign. So I'm registering it with my IP address, and then we'll try the Echo client again here. Hey, let's see if it goes here. Test. And the server replied test. Okay, so now I'm actually getting it over the network rather than the Echo client. Let me see if I can get yours going here too. So having Wi-Fi trouble. Let's see. Should be on wireless. Yeah, so it might not be picking up. But it's funny because extra still free in this thing. Okay. You saw the back one there? No, so oh, it's time to set it one. Here's my address on the Mac. We're getting there. Let's see. Uh, This one might be it. No, no, that's not it. No. Ipconfig get IFADDR EN0. That's yeah. That says maybe for Wi-Fi. It might work. Yeah, give it a try. Space get IFADDR. Yep.
Oh, does that?
Mhm.
All right, I got 151,
151.
141.
Oh, 141.
Yeah.
Yep.
5.
Yep.
230. 147.
Okay. Should be pretty close.
What was it?
No, I just want to make sure we're on like the same, but it's a different subnet here. I don't know if that matters. I don't know how they do all their wireless here. Let's see, because that'll be helpful. That we can work. Does anyone have a Windows computer? We all have Macs.
Normally I have a Windows, but I can bring my sisters here today.
Okay. Okay. I can try. Let's try the phone hotspot for fun here. So we'll try getting off the wireless network and try it off my phone network. Can you connect to my phone Wi-Fi real quick? It's the Galaxy 23 FE network. Yeah. Yeah, the password's 1234567 for the Galaxy S23 network. All right, so I'm gonna end my Echo client. Stop this one. Did it get connected to it? All right, sweet. So I gotta check what my new address is here because that's gonna change. So now when you run that ipconfig command again, it should be something like 10.204.
Yeah, 185.9.
Okay, sweet. So probably a new address there in your main for me. I'll be 204.185.187.
I'm sorry, mine and then 49.
Yep, that's fine. So usually the first three sets match. There's a whole networking bit here you can go learn about, which is lots of fun. Yeah, put mine in because you're going to connect to me when I run my server.
Yep.
You got the same thing?
Got the one, 2 man. 185. You got control? Okay. Yeah. You can 415. You got 185. You got 185 dollars. What you will buy? Then oh, then you go and then you go for not not it's 10 years. Yeah.
I should have brought my other computer. So I should have done. Sorry.
No.
All right. Well, that's not very exciting if we can't get it working over the Wi-Fi. Just want to make sure it still works on client side. Yeah, it's working okay so far. Got a test. Go another one here for fun. Documents, GitHub, 96. Client. Oh, I want to open another one. OJ. Do I not have 3 open? I want to run another client. Try the other community version. Come on. 6 echo clients. Right, enter a message. There's test 2 from client 2, and then the server got test 2, right? So the same server process, right, is listening. It's got this little while true loop that all it does is sit and wait to accept connections on the socket. And that's the idea. So we say, hey, I'm going to listen on this specific port. We just pick a large number, right, somewhere less than 65,000, but higher than whatever that range was here. And we say, okay, I'm going to listen, and now I'm going to use this, instead of localhost, I'm using my public IP address, or my computer's IP address. Ideally, other computers on the network can get to it. I'm not sure why your Mac isn't here. I'll bring my other laptop next time. Actually, we're not meeting again, are we? We'll see. We can always run the demos on one laptop as well, if you're having trouble connecting, but it should usually work. I'm not sure why it's not for you guys here. No route found. Route found to host. Network. Okay, it might be this local network access for your applications. So that when I first connected on my Windows computer, it says, oh, hey, do you want to allow Java to connect to the network? And it prompts you. I assume Macs might do the same thing. It could be related to this because you're going to need access to the network on Mac land. So you can give that a try. I'm not super sure with Macs, but it usually works. But anyway, our server is sitting and waiting, and then all it does, excuse me, is start threads. So when it gets this connection here, it receives the connection, it kicks off a thread that's handling it, right? This runnable thread here that handles the client request. So this one here is doing the sitting and waiting for client requests, right? So as I am open here, here's, oh my goodness, file sync. We didn't change anything, did we? I confused IntelliJ apparently. Here's the first client, test 1. Right, the same server, it got the response from test 1. The connection's still there. So we still have the connection open. So this thread is still working. So we're still handling that client request here on the runnable thread. Right, we've started the thread here to handle that connection. So as we get stuff, as we write, so we have a reader to get input from that socket connection, and we have our output to send stuff through the socket connection here. So as long as there's something to read here, we're going to go read it. Yeah.
One question. What exactly is this?
So it's a specific connection on a specific port that we've opened. So we said, hey, I want this socket connection to listen on this port. That's how Java does it. So we say, hey, I'm listening. Here's my address. Here's my port number. Here, this is the socket.
Like an endpoint?
Yeah. Yeah. Yeah, it's just a specific endpoint. So as long as there's something to read, it'll go read that data and write it here. When it's finally done, we can close our connection here. When we're done, that's going to handle it, right? We're just going to keep on waiting as we get client responses. Right? We don't see another connection coming in, right, on different ports. It's been connected. So I can keep on sending messages through here. Test 1, test 1 again. Right? We keep on sending messages through. On the client side, it's just going, right? We've got our socket here, and we're sending messages. As long as it's not null here, when it's finally null, when the server stops, this loop will stop. So even though there's nothing to read, it's waiting to read. So this read line, remember, like when we do a console read line, or our system, the scanner.read line, right? It just sits and waits. So the read line command is just sitting here waiting for something to read, right? It's going to wait to get that response here. So this loop is what's still running here in our Java program on the client side. And then as it gets data, right, as it reads something here, it will go output the data, right, and then it can go send something to the server, right? We're going to go write it to our socket when we give it something to send, and then it's going to go read the data from the socket reader, read the response, and be done. And it's going to come back, okay, is there more, right? Is there more for me to read? Do I have something to go here? Let's keep on sending, let's keep on sending, let's keep on sending. So that loop keeps this up and running here for each thread. So the more clients I have, the more threads I'm going to have active on my server, which is okay for now, right? I can handle several threads all at once, right? The idea, it'll have a little bit of time on the processor, a little bit of time on the processor, a little bit of time on the processor. If I've got 1,000 of them and they all want processing time, it's definitely going to slow my computer down. But if I have just a couple and I'm just waiting to receive messages and send something back here, I can leave the thread. It's just going to sit there hanging out. Now, it'll use some resources here, but we can handle it. The one machine can handle this process here and go and connect. So this sort of system doesn't scale well to the lots and lots and lots and lots of clients here. This would not work well for actual Discord, right? To run one real Discord server here, they don't just have one process that runs everything, right? They have to deal with how do they have lots of different servers handle lots of different connections, right? And you can do that. You can have different servers that have different connections, and you can farm connections out. And there's cool things you can do with networking land here, where you get connections and you don't, you've never plugged in someone's IP address before to connect to them, right? We use that domain name service DNS. So I say, here's the website's name, and DNS says, oh, okay, here's the website name, here's the actual IP address. That's where I'll actually connect to when I send my request through. So you can do cool things with in networking land to deal with it. But on the server side, we can just set up a connection. We can just start running. We'll just wait and go here. We can spit them out. Did this one ever finish here? It didn't. I don't know what I broke with that one. I think maybe because it's both open here and I recompiled. Not sure. Excuse me. Now, this is pretty easy if I just am connecting in to send a message and back here. There's no user login process. If we had to log in as a user or like tell the server process who I am, we'd have to give them our information, right? Here's my username, here's my password. And the server has to go look it up and make sure we did it right? Is it the correct username? Is it the correct password? Doing user authentication by yourself is very fraught with errors here. That's a common issue, and security vulnerability is people doing their own authentication. That's just what it is, right? If reinventing the wheel is hard. So there's some common authentication protocols like OAuth here. OAuth 2 or SAML's another one. So this is more specifically web-based here, but just so you know, there are better ways to do this than by just sending your username and password across here. But that's what we're going to do to simulate it. We'll make a little users table. I'll have a password table, and you'll tell me your username and password, and if it matches, I'll assume it's you, because you're probably the only one who knows your password. Right? I'm just admitting that's bad. Okay, not a great way to do it. There are better ways to do these things. They're standard processes. We're not going to go through and do all of that for a little demo app. Right? That's not really the goal of this here. And again, this is more based for web applications, although you can do these sorts of things. Like remember when we first logged in with the GitHub desktop client, it said, oh, you have to log in, go to the website to log in. And it launched out to the website, and then it launched back to the application. So you can farm that process out here. Is just more complicated as we go here. Get this to quit, maybe? Try task manager. Come on. This one. Let's kill that one. Oh, it's using a bunch of CPU. Oh, because it's processing those file changes here. We'll just kill it. So I opened the project in the newer version and the older version. Oh. So they were both open and I ran them both, and I think it probably just confused it here. So hopefully that should be fine here. And we're still just sitting and waiting and good to go here. All right, cool. Yeah, we got our message. So this will just stay open here, right? We have the connection is held open. So we can send stuff back and forth here as we're going. So we could change our process here if we wanted to do something different with how we handle these client requests, right? So we can say, hey, there's different types of requests they might send in. So maybe they're going to tell me, hey, this is a login request, or this is a message request, or this is a I want to get my chat history request, or whatever we want to do here for building out our little chat application. Right? So the first one's probably login, and we could even skip the password part here because we know that's just kind of silly at this point, and just here's my username, I'm online. That's terrible. No one should trust that. But again, this will just be a quick little demo here. And maybe one of the things we can do is get a list of users that are online. Right? We'll have to keep some list of who the active users are. Yeah.
What is it with the user application and a regular API that you do? What's the API?
So the piece that you connect to is the API, the application programming interface. So whatever piece we're connecting to. So we're building an API that listens on this port number here at this point here. Most of the time you build them out much more nicely here, and it's not, you have to send a specific text over a socket. That's a little bit obnoxious here. So web APIs are very popular. We can do things with web requests. And I think we did that with Python. It's pretty easy. Just go out to a website, send a request, and it sends you data back. That's a much more standard approach here. But this is building out anything custom that we want here. We can do the custom bits here. We could actually build one out as well, like that listens on port 80 if we wanted to get web requests. It would just be a really big headache because then we'd have to deal with HTML requests coming in and stuff like that. And so you can write your own web server if you care to. That's what hang on, image is Apache. Apache's not Java, is it? Oh goodness. What is it written in? I don't know. I don't remember what language they wrote Apache in. Oh, written in C. Oh goodness. Okay. So that's a very common web server. Was just written in C. You could do the same kind of thing in Java. It would just be obnoxious because you have to do a lot of moving pieces to deal with a web server. They do a lot of cool things. So it's nice when other people write software for us. All right. So let's keep. Let's leave these examples alone so that they're runnable here. I'm going to put them back to localhost instead of this IP address because that won't work for anyone else here for the demos. I'll put it back to localhost here. I can turn off my hotspot since that didn't work very well for us. All right, and then I'm going to go copy this project out here. So let's go this one, 96. So we'll call this one our chat server. Okay, so I can open this one up here. We'll just start with this as the basics here. It won't be super interesting, but that's okay. Documents, GitHub, 96. Here's our chat server. So things that we need to know for our chat server. Right? We're going to need to keep a history of chats at some point if we wanted. Again, it'd be nice to store that in a database somewhere, but or maybe we don't. Right? We could just keep it all in memory, and when the server shuts down, all your chats are gone, and now we're the new Snapchat or something, right? Look, we don't keep your. I'm sure they don't keep your messages, right? They would never keep our messages on Snapchat. I'm sure.
How would they do it?
Yeah. There's a lot of money to be made in mining people's data. And if people are talking about products that they're interested in, you can sell ads to them about the product they're interested in and those sorts of things here.
You can sell the data.
Yeah. Facebook apparently buys massive amounts of data about their users. You'd think they'd have everything about you, but they buy even more to give you better targeted ads. And that's how they make their money, selling ads. Did you guys see the clip of the really dumb senator who asked how Facebook makes money? And Mark Zuckerberg was like, we sell ads. Like the guy didn't know this. It was really depressing. Not that I really had a lot of faith in Congress before, but when someone doesn't know how Facebook makes money.
I think it's that old.
Well, and this guy is like 90 years old or something ridiculous because once you get a job in the Senate, you never leave. You just die or something, right? Now, what's the average age? Hang on. this total rabbit hole, but it's fun. Average age of U.S. Senator. Pew Research. Median age of senators is 64.7. More than half of them are older than that. That's median, right? That's not even the average, right? Does it have the actual average? Uh, Median age has just gone up and up and up in the last couple Congresses. Amazing. By age and generation, we still have. Let's see. I don't understand these pictures here. I'm really confused. Oh, ages. Okay, that's what it is here. This is a generational gap here. There are 5 millennials. That's actually kind of impressive. People born after 81, apparently. 28 Gen Xers, 60 baby boomers, and 6 people born before 1945. One person 90 up, 5 people in the 80 to 89 category, 27 people in their 70s in the Senate representing us here. 33 of them, so that's a third of the Senate is in their 60s. Barely anyone's younger. So anyway,
That's very bad.
it's by seat count, but yeah, that's a weird way to do it here. I don't get it.
And the college is super like.
Yeah, bad color ranges. Can definitely do better. If they've got one Gen Z in the House representing you folks, who is the Gen Z member of the House? I don't even know. That's all right. Anyway, we're building out our chat server. How did I get on coffee? I've had a lot of coffee today, guys. I got up at 6. It's way too early. All right. So what we need to do, right? We need to have our list of users, right? All this from listening to our users' data and being Snapchat. That, yeah, okay. Yeah, we can sell data. Yeah, so we'll make a lot of money selling people data who want to connect to our chat server here, right? That's the real ambition here. We'll just make a lot of money off this product because it's going to be super good here. Everyone's going to want to download Java and run a Java application custom, right? We can build a mobile app, right? You can do cool stuff. Anyway, so we'll wait for connections. We'll get connections, and then we'll go and handle those requests. So as we get connections, we need to know who's connecting, so I can have that list of active users, right? And then if you want to chat with someone, you can tell me who you want to chat with, right? We can then get that chat session up and running, right? That sort of process perhaps here. So we're going to try and make that connection, right? We'll go set it up here. We've received from a client here, and then the message probably needs to be their name or something like that, right? Who this person is here. And then we can go output some kind of message. This one's just echoing here. It's just whatever they sent me, I'm going to send back. So we don't need to do that here. So this is the part that's going to change initially. And then every time they send us a message, right, we need to be routing that to the correct person, right, if the other person's connected. Maybe we have it here, and then we can go give them new requests. Right? Hey, I've got a new chat for you to listen to. Right? So let's see if we can keep something here. So let's have maybe an array list string for users. You just keep a list of who's logged in. We should probably use like a dictionary. That's probably even better here, but it's just a list of users here. Okay. So we'll go set up users then. Starts blank. Users equals new array list. And as people connect here, we can go and connect them in. And we'll go add them to the list here. So the first thing they're going to do, instead of just giving me their username, or instead of just giving me some sort of message here, the first thing they should say is, okay, here's my username, right? I want to log in. So maybe every request will come with what action do they want here, and then what's happening after here. So we're going to have to parse some of these messages here, all my input messages. We're going to have to figure out what's happening here. So I can say, hey, if my in message starts with login, right? We'll go do the login thing, right? Else if my message starts with something else, right? Sure, log out, or else if my message starts with message. Look at that. Look at these suggestions here. It knows what we're trying to do here. Sure. I don't know if they train off of ours or just all the stuff that was online already. I'm not really sure. I've not actually read their privacy policy to see what data they train with. Nobody reads this with 50-page documents, right? All right. So if it's login, then right now we'll go and add them to my user. So my users.append, no, add. Now I don't want to add the login part here, right? So I want to take the substring of that. So I'm going to take my in message substring. Let's just take, I don't even need an index. That's 5 and probably a space. So we'll just do starting with 6 characters, right? Strip off the login and a space here, right? Now we've got a user, right? And then we could, again, just do our own prints here. We're going to keep a little running log of what's happening here. Added user. I guess let's do that. String username is the substring. Username. We go add the user here. Right? Again, we haven't built everything out, but now I should be able to go send a login message here on my first connection, right? And then tell me the user. Again, it'd be nice to do something with a password, but we'll just skip over that because that seems like it's going to be a big hassle and it's not even going to be a good implementation anyway. So who's logged in my chat, right? And then maybe if they want to get a list of log out, we can remove their username. Sure, we can do that. Remove the username, logged out user, logged in user. Just remove their username from my list here, right? Let's get list users. So if they want to get a list of users online, like who can I chat with here? I think it'd be nice if we could build out, like, I have a friends list and I can see which of my friends are online, but that's lots and lots of features. It would take a little while. We're starting basic just to give you the idea of some of the stuff we can do with it, right? Now the other issue, if we're adding and removing from different threads, we're going to be a little bit careful here that we don't clobber stuff. At this point, it's probably pretty unlikely, right? We're not going to have dozens of users here. We're not going to have lots of connections all happening at the same time. But we could add some of the concurrency safety stuff around here if we needed to. At this point, it's probably not worth worrying about, right? Trying to make any of that a little bit like locking or locking the object before I make changes on it. It's not going to make that much of a difference right now. All right, so I list users then. I need to respond with the list of users. So far, we haven't really responded with anything here. So I might want to actually go write something to them if they've done it, right? Like log in successful, log out successful. If we wanted to give them some kind of message here, we could do that, right? So we'll have our message then. We want to write logged in. Log in successful, right? Sure, why not? And then write a new line, flush, sure. Log out successful. And if we want to list users, then we're not going to just write one thing here. I need to give them the list that they can go parse, right? And whatever format we want to use with this, we could. Right? We're going to define what that format is for transferring the data back and forth. And we can do it anyway, right? It doesn't have to all be text-based, right? You can transfer binary data if you want to, like we can write binary files if we want to. That's pretty fun. But then it's a little harder to deal with and troubleshoot and that sort of thing. So we're going to use text because it's easier for us to see with our examples here. So I need to build out the string of users here then, right? Starts off as nothing. I can do my string, is there a join? I'm going to join a comma with my list of users here. There we go. Equals. Doesn't like the user. Hang on. Might not have been initialized. It was initialized. was. Okay, sure, we'll do it up here, I guess, then. Why not? Now is it happy with users? Really? Why not have an initialized? Oh, goodness. No, okay. That's why. That's the wrong variable here. Return message. Sure. There we go. If I don't use the same variable name here, it's a little bit happier. There. So we don't try and do the wrong thing. Do we do string join? I think that was way back when in the book. Some common operations you can do with strings. Instead of having to say, hey, take the first thing and add a comma, take the next thing and add a comma, take the next thing and add a comma. Once I get to the last thing, add a comma, but then delete the comma because I don't want a comma because it's like it takes care of all that for us. So it's just going to put all these strings together with a comma between them, right? So nice little comma separated file here. So then we'll write our message here, add a new line, and flush out the buffer. That's the list of users, right? So if they ask for a list of users, we'll just give them the list of all the users who are logged in here, right? And we don't need to do any of the echoing stuff there, right? And if it's not one of those, right, maybe our else case is we write, unknown command or something. We should probably tell them we didn't know what to do here, or what, like give them 503 error or something silly, right? Web requests 404, yeah, 503, service unavailable. Doesn't have the not found. Unknown command. Right? So at least we'll give something back, right? Whether or not it's the actual thing or not here. We can go give it back here. All right, so we've got our server, should be up and running. Let's go copy our client here then. We go grab our echo client, copy this one. This will be our chat client. Let's go open that one. Excuse me. Open our, chat client. All right, so again, it will connect here, but now we're doing something different. Right, so we have out messages here, and we get responses, what's coming in from the server here. Probably okay for now. We can try it and see, right? We can do our own commands, essentially. Let's see. So let's run our server here. It's our client, chat client. What happened? What's happening here? Did I open the wrong one? Why do I have them both? What happened to my server? Okay, here's the chat client. What happened to my server? Open 96 chat server. In a new window. Oh, I probably hit this window, didn't I? Okay, so now we've got the chat server. Okay, so we can run our chat server. Waiting for a connection. All right, so now it's up and running. Again, just waiting for local connections here. We're not over the network. Didn't work out so well, but we can play with it later. Then we can start the chat server. We'll connect hopefully the local host at that port number here. And then it should wait for us to send a specific message. Okay, we got a message here. And then the chat server said, okay, we got a connection here. Good. We're from this port, right? It picks a dynamic port to connect into. So I know when I send it back on this port number, it will go to the right process. Yeah?
In case like you're working with a game, so you were gonna have other people connected to your server.
Yep.
And the game's gonna run from the server side.
Mm-hmm.
So is it capable of having like three people sending data, like let's say the arrow between the same time?
Yeah. Yeah. So if you're updating an object that's not thread safe, you just want to be a little bit careful. You might have to do the locking stuff with it, but there are thread safe concurrent dictionaries and things like that. Some of the stuff we looked at last week you can use to store that data, but it can handle multiple connections all at once, definitely. Right? I had 2 up and running. We can get more than that here eventually. Yeah, it'll just, whatever you tell it to do, it's going to run it on that thread, right? That's one of the reasons we use threads, is that I can handle different requests on separate threads, and they all just kind of sit there and do their own thing, because it keeps that connection open live with our sockets here. So where like web requests, you send a request out, there's not really a live connection. Right? I send a request out, I get a response back, and that's it. We don't keep anything open here. I just will send more stuff and get more responses here. So this like keeps the session open. with the thread. So, and you can have multiple ones here. So right, we got the connection here. So in the client, then we want to say login Eric. It says login successful. Okay, so on the server side, it said we received from the client login Eric, and we logged in user Eric. Okay, so now if we want to list users, we should get back another, right, that Eric's logged in for my chat client. So if I say list users, we get Eric's here, and that's the response from the server. Right, cool. So what if we say login Jeb? Right, login was successful for Jeb. So if I want to list users here, we get Eric and Jeb. Cool. Right, now we can try a log out. Now, I don't know if I fixed this, right, on my chat server, this one here. We do a log out. Um, log out has 6 letters. Login has 5. So I probably should have changed this number here if I was expecting a space. Right, that's my bad. And again, hard coding these sorts of things, that's why magic numbers are kind of bad. And we could do index of and find this exact same string, or you could do smarter things here. So obviously I did that as an example on purpose to show you that bad stuff will happen if you try and count numbers by hand. But cool. So far we can list users here. Right? Now if we want to chat a specific user, right, or if we want to like start a chat session, right, I need to say, okay, who do I want to chat with? Right? It has to be a user that's online. Or we want to just like send them a message, and then the next time they log in, we can get their list of messages, or got a couple ways we can handle it. Let's see. So we got our list here. So if we wanted to send a chat, right, to somebody here. So let's go and see what we want to do. If it starts with message, right? So we'll get the message that we want, and then the next piece should be the user that they want to message, and then the third piece should be the actual message, right? So the first bit here is just, hey, they want to send a message. Then the next bit is what user they're trying to message, and then the third bit is the message. So we have to go and do a little bit of parsing here, right, off of this. So I can get, I don't know, here's the string array for tokens or something is in message dot split, and we can split on space. So the first token should be message, and then there's a space. The second token should be the username, and then the rest of the tokens are going to be the message. There probably have some spaces here. Or we could go look for spaces and trim off, find at the end of message, look for the next space, the index of space. Is that easier maybe? We can do that. So we can have the string for the username is going to be my in message substring of what I want. So message is how many letters long? Is that 7? Right, plus an 8. So we'll start at 8 characters. And how long of a substring do we want here? Well, we want to go until we find the next space. So we want to go in message dot index of a space character, right, starting at 8. Because I don't want the first space, because the first space is after message. I want the second space. And so just handling strings, doing some string parsing is not super exciting here. But the username should be between the first space and the second space, right? Or after the word message, right? Up to the next one here. So now I got the username, and then the string for the message is everything after that second space here. So maybe we even want to track that here. So int index of second space is this one. Oops. Right, then we can use that. So that'll be my in message substring index of the second space +1. Look at that. It knew I wanted to do +1. That's really clever, right? Because it'll stop at that character but not include it, and I want to start after that character. Right? So that's the rest of the message, everything after that, right? And then for now, well, let's just, here's the message here. So we need to go and save that and send it to the other user, right? They've started a chat here. So they sent a message out. So we need to go get that message, send it to the other user here. Excuse me. All right, so we don't want to send it back to them. So we can I don't know. I guess we'll just write the message back. I will just echo back to them for a minute here to see. Let's see if we can get the message through. So we'll try it for a second. So um, see if we're parsing it here. I don't need to do anything with the username. That's okay. Come back to that. We'll run our server again. Rerun the client again. Actually, I probably could have kept the client. Oh no, I need to reconnect here. Okay, so if we're going to log in for Eric, you logged in successful, and if you wanted to message Eric with test message here, we got back the test message. So it looks like we successfully parsed that test message here on the chat server, right? This was the message, Eric test message. That's the line we got here. So we're getting it here, and we just send back the message again. We need to do something different with it. We're going to have to route it to the right person, right? Well, we've got the message in, right? So they can send that message here. Now maybe let's add a list of messages. I have 2 semicolons there. That's fun. So I've got the list of users there. Let's actually make this static. We do a dictionary, a concurrent dictionary, current, do a hash map. I think that's what we want, a concurrent hash map. That should be thread safe for us here for a given string. And then we can use an array list of string here. Call it chats. Look at that. It knows we want chats. I'm so impressed with this. It's so fun. So anyway, the hash map is like our dictionary. It maps something here. Here's the key. Here's the associated value. So what we can have is the key of your username, and the associated value could be your list of messages. Right? We'll just have a message waiting for you to, here's the message that you got, right? So we want to go add this in here then. Let's see. So instead of adding the username, we'll take our chats. So when we log in, we want to go add here. Put. We want to go see if we have one here. Let's see. Remove. We don't want to remove. Where's our which key we can get here? Yeah, I think we can do a get. That might be fun. So we want to see if there's a value associated for this user yet. Right? So maybe we've got some messages waiting here for this user. Because I might have sent a message to this user, but they weren't online, so we weren't able to get it to them. We can go see if we've got any here. So we can use a get here. We can have an array list of type string. The messages is the chat for the username. And then the default here then is an empty array list, right? If we didn't have anyone. Contents of are updated but never. Oh, okay. Yeah, we never checked here. That's fine. So if there was one, we'll go get it here. If it's empty, then we can go log them in, I guess. So if messages, no, dot size is 0. So if we had no messages, then we can just go add our user here. They didn't have any messages for us. Why is it not like that? Oh, it is empty. Okay, sure. If it's empty, take our chats and we want to put. Oh, there we go. Put if absent. That's even better. I love it. It's a great suggestion. So if it's empty, no, wait, I'm sorry. Getting too many good suggestions. So if we just try and put, if we don't exist here with an empty array list for the user, okay? If it was existing, then we've got messages. We can go then spit out all the messages. Hey, you logged in. Here's all your messages that you had here. So then we can go and get, so our list of chats, then our messages, our list of string, messages, will be my chats, forget the username. So if it wasn't existing in our dictionary, we'll go add it in with an empty list of messages. If it did already exist, right, then we had a list of messages, we didn't add anything, we'll get all the chats here, and then we can go through and read off spit out all the chats to the user here, right? Then so like for string message and messages, we're gonna go right. Here's all your messages. So we can take all this and we can go spit out messages. Okay, here's the chat you got. Here's the next chat you got. Here's the next chat you got. Here's the next chat you got. And we successfully logged in here. We read their messages. Now, after we've read all their messages, we can probably get rid of them. Right? We don't need to keep them here anymore, right? Because they've gotten their messages. We don't need to keep them on the server. If we wanted to keep their chat history, we could do it a little bit differently. We'd have to timestamp stuff and say, hey, when was the last time you got your messages? Then we give you the new ones from a given timestamp. That's getting a little bit trickier, but if we had a database, it'd be much easier to back that up with a database here. We're just working through our first example. So we could add in those other cool features later. Right? Leave yourself a note, right? Nice to keep in the database and use timestamps. Because then you never have to get rid of stuff. But we're just doing this all in memory for right now because it's quick and easy here. So after we've done that, then I can go and clear out all those messages. So I've read them all. So I'll go and update then chats.update. Oh no, not an update. What is it here? I want to just put, yeah, we'll just put then a username with a new empty array list. Okay, put a new array list in. There's no messages left to read here. We're good to go. Okay, so read them all out, get them. I guess we could probably even do that this very next line here, right? We'll get all the messages and then blank it out and then go through and read them because this might take a little bit of time here. This way we are hopefully a little bit more in sync with our thread accessing it. I'll move, so my comments lie, right? For now, we'll just delete them. Right? We could remove all, but that seems obnoxious too. Right? We'll just update. Send all the messages. So you log in, here's all the messages for the specific user. So when you send a message to somebody then, we need to go and add it to their queue. Right? So we need to go see if they're there, right? So maybe we get the messages and add to it. So we can get our array list of strings, messages is chats, get for the username, right? And then we probably want the get with default, get or default, new array list. So if it's didn't have any messages already, or if they didn't exist, right, then we can go through, get a blank one here. We'll go add the message to messages, and then we can go update chats. Right? Go put the username, the new array list of messages. Go associate that array list of messages there. Right? If we're getting references, we might actually be updating it live. I don't know if we need to bother updating it here if we've added it to the array list, but it feels safer. Unless we got a copy of this array list here. It's probably safe to just add it, but that's okay. All right, so we'll go and add that message then, right? So we've got it. So we've said here's from the queue. Now the only thing we don't have is who it's from. Right? We didn't track who it's from here. It'd be nice to tell them who the message came from, right? Pretty helpful. So when we log in, we could track that if we wanted. So I know this person is logged in, but then like I was able to log in twice. I don't know, it might get a little funky, but that's probably okay. So we'll have like a logged in user here. Right. So maybe we can do that first. And then maybe if we get a response that is anything other than login and we haven't logged in yet, we could tell them you have to log in first. Right? We can add controls around stuff like that. So we can start that. So I'll have a string for current user. Starts off at blank here. And then if we get a message and it's login, great. We can then go set the current user, right? Current user is the username. Other than that, then we want if it's a message, right? And current user does not equal blank. Just a blank. Is it not like that? Oh, yep. Dot equals, sorry, blank. And not equal blank. Why is it not? Is empty. Oh, okay, sure. Is empty. Replace with is empty. So if we have a current user, right, then I can do a logout thing. If I have a current user, then I can go and list here. right? And I need to know my user is active here. Otherwise, an unknown command, or maybe we can tell them, hey, make sure you're logged in, right? No command or log in first. And we can do better checks here. Sure, we can do that. So otherwise, then, if my current user is empty, we'll tell them log in first. Otherwise, it's an unknown command. Right? So all of this so that once you've logged in on this thread, we know who the current user is, right? That we're working with here. We can set that with login, and I can use that for all that. So when I send the messages, then I want to, before I go append the message, right? I want to take message. I want to do the current user. I'll take my current user plus, I don't know, like a colon or something, plus my in message substring. So we'll say, hey, it's from this user, right? So we've got that list here. So let's see if we can get a message into the queue for somebody. All right, so we'll start the chat server here, waiting for a connection. We'll come back to the chat client. Now the client itself isn't really changing right now. Not doing a whole lot of interesting stuff here. It's just when it gets a response, it'll read it here. So we're going to log in with Eric here. Let's see. Logged in Eric here. Cool. We got no response. Okay, did we take out the response? We must have, right? We did a login. Login. There were no messages here. Oh yeah, we never told them, so I took out that. Oops. So we should do the login successful first. You can tell them login successful. Login successful. Right? And then we can go through, if they have any current messages, go tell them what their messages are, and then go from there. All right, so I did log in, so I should be able to message somebody, right? That should put a message in their queue. So if I come back to my chat client here, and we want to message, we'll say it's message Jeb, test message for Jeb here. Chat server hopefully did something here. Let's see, did it go to message? Logged in. Oh, we took out all the logging here. I like having it log messages here. So it should have put the message here to our chat client. Looks like it didn't get through here. What are we waiting on? Chat server. Got the login. Didn't like it. Socket writers. Oh, we should have written out the message here, so we didn't get something. Chat client. We sent the message. Okay. Oh, I think it was waiting here to read a message back. Let me stop that in a second. Because we go write our message and then we try and read what's here. There was nothing for it to read. I think we confused it with our client here by not outputting something from the server. So now we're telling it login was successful. Hopefully that's a little happier. And that's only a single line. We might need to read more than that as well. Let's see. I think we need to read all of them. Let's try it and see. So we've fixed our chat server. So we're going to respond. And then we can try the client again. And then the client, we'll run the client. So login for Eric, login successful. Okay, now we get our message here. So message, Jeb, test message here. Okay, and now we get test message from Eric. It was logged. Cool. So we sent a message in. So the next time Jeb logs in, he should get the list of messages. Right, I think was the idea here. So let's say quit for this one here. Bye to quit. There we go. Bye quits. The server's still up and running though, right? Chat server's still up and going here. We run the client again. So it's got all that information in memory, right? We haven't used a database or anything yet here. So say login for Jeb. We get login successful. Oh no, where's our message here? Chat server, log in for Jeb. Logged in the user. Do we ever get messages? Let's see. I think this is because probably because we didn't. Oh, we write to login successful. Yep, that was login successful. We didn't read the next line, so I think this got written to the socket, but we never read it here. So we need to go read more. Stop that a second. We'll stop our server. Oh, we broke it. Well, when the connection got reset, that's fine. It's still running. So let's go print it. So this was like a while. Socket reader. My socket reader dot ready read line. Which one is it here? Read. We're gonna keep on going if we have more messages. Okay. Let's try and read another one here. While my in message is not null, might be not null. We'll see. Print it all out and get the next one. And print it out and get the next one. We did our logged message, right? We logged a message, put the username. We didn't spit it out, did we? We need to just spit out. We put a message in. Log message or save message. The message. Just so we can see that it's happening on the server side. All right, waiting for connection. Back to chat. Start a chat client. Log in for Eric. All right, we're logged in. We want a message. Jeb. Test message. Did not get it? I broke it. I sent the message. I think because there's nothing to read. There's nothing to read. Hang on, I gotta put it in debug mode because I don't know what it's specifically setting it to here after we read our message. The login was fine. Let's try it again. So here's the server. Right, waiting for a connection. We'll go back to client. To log in as Eric. All right, here we go. So we got our read line. That login was successful. And we're going to try and read again here. What do we get when we try and read again? It's just sitting and waiting for more data. Shoot. Okay, so it's not. Oh, goodness. Reader. More data. Available? Okay. Some. Check the value. Okay. So while it's not 0, let's try that. While my socket reader dot available. No, but not in. Available. Not available is not 0. That's not the socket reader. It's the input stream. Client reader dot. What do we have? This one doesn't have the available. Shoot. Socket reader. Socket. Buffer reader. Dot. Is it ready? I don't know if ready is the right one. Hang on. Sorry, this one's not the right one that we wanted. Stream not available. Socket reader. Wait for more to read. Get input stream, buffered reader. Read line. That one's not it. Need input stream. Data. Input. Not the end. Oh goodness, that's doing like bytes at a time. That's obnoxious. I don't have to do bytes at a time. All right, that's unfortunate here. All right, forget all that then. Let's just do it one line at a time because that's easier for now. We'll come back to it after. So we'll just fix the server for a minute because I don't know off the top of my head how to fix that right now. So we've got to change it then so we're not doing one line at a time. We're going to do a single response then for their messages. We're only trying to read one line off that socket here. So we'll have a single message, return message, string. Return message is login successful with a new line here. And then we can go add to that return message here. So rather than writing it right to the socket every time here, we'll go take our return message, add the message, plus a new line here. Yeah, sure, we should use string builders, that's fine. Then eventually when we're done, then we'll go and write that message out just once here. I think all that has all the new lines. We shouldn't need that one here. Here's the return message. That should be a little bit better. Right, here's our client. Log in for Eric. Message Jeb, test message. This one's done. We can quit it here. It should have that message. Let me go log in then. Log in as Jeb. Login successful. Oh, we didn't get our messages though. Shoot. Not get received message. Save the message. Test message. This is Jeb. I must have screwed some up with our dictionary here. Should have done more debugging. Let's see. Oh, we still have users. Are we still using users? Where are we still using users? Move. Okay, that's fine. List of users. Okay, didn't fix that. Message. Added the message. Logged them in. We didn't get our message back out though. Message Eric. Test message. Try one more time here. Log in for Eric. No messages. Okay, all right. Let's go put the server in debug mode. It looks like we're not getting our messages back out here. So let's run the server in debug mode, and then go run our client again. Log in for Eric. All right, cool. So we got to log in here. This is great. We'll just continue. Got our chats. And I'm going to send a message. So we got a message. Jeb, test message. Right, put the test message in. Great. And then I finish this one here. And I'll run it again. Log in as Jeb. We'll see what we get here. So we've got our chats, right? Eric has, okay, so Jeb has a chat, looks like, right? The value associated with is the test message. So we should have it here. So if we go get for the username, Jeb, it should give us our messages. Let's see. Messages, yep, has a message here. And we're going to put username. So we've got the messages. We're going to go delete the messages then. An empty array list. And then for every message in messages, there should be a message here. Let's go add it to the return message. Login successful, Eric test message, and we're going to go write that to the socket. Login successful, flush the socket, successfully say we logged in here. Okay, logged in the user job, our chat client. Got the login successful. Where's the rest of the message? That's it. That's super weird. Where did it go? Did read and maybe read line broke? Oh yeah, read line broke. Let's go to read. Break it. Because read line is going to stop at a new line character. So we screwed that up. We wanted everything. We want to read all of it. And all right, forget that then. Hang on, let's go fix it. So instead of adding more new lines here, login successful. Here's messages. Socket writer writes the new line. I think this one line at the time is annoying. I'm sorry. All right, back to the client. We're almost there. Login as Eric. Sysjub. Test. Log out. Run it again. Log in. Hey, all right, now we got our test message. All in one line. So it's all because we're reading one line off the socket. That's been the problem here. All right, we got it. We're able to add messages to that concurrent dictionary. So we're thread safe. We got data there we can share. We can go get some of that data back out. Again, just on the login here, we're not quite up to having an active connection yet. We've got a way we can put data in and get the data back out. So far, one line at a time, but that's okay. We'll come back and we can fix this up a little bit later. Why don't we take a little break? We'll come back in a couple minutes. See if we can add maybe a UI to it, because we're going to do something with a graphical interface. Should be a lot of fun. And then wrap it up tonight, okay? All right, cool. Let me go pause this. All right, now I remember to hit resume here. So we're going to go over Mr. Liang's example with the tic-tac-toe server he's got for the website. Put a lot of work into a book. It's great. It's really expensive. It's from Pearson, and I hate Pearson because they take a lot of people's money. But anyway, here's a good example. So, and you can go to the website and go find his example. So it runs a server process here to play tic-tac-toe, and it uses a constant file because sending integers back and forth is a little easier than dealing with strings. So he's got his ints here that all are just static integers here. Sure, so that's how he sends data back and forth. So the server starts up as a Java FX application here, and all it does is the server bit is just a text log, like a text area, so you can see what's happening, right? It's essentially logging to it here. So it starts a thread. Now, when we're dealing with Java FX here, you've got to do this silly nonsense that says platform run later, because the same thread can't be updating your Java FX interface as the thread that's running. So I think we talked about it just briefly last week, like you don't want your UI to lock up. Bad stuff would happen. So if we're dealing with threads and Java FX, you have to tell it, hey, do this later on another thread anyway. So this is our little shortcut to run this process later in our platform, right? It'll run it at some point here when the FX interface is getting updated. So it's the way it's designed here so that we don't block other processes. So you tell it, okay, go do this thing here, right? We started a server, and then it just waits. So every time we get two people to connect, it will go and let those two people play a game. So yeah, it's not tracking who's who. It's not doing any of that stuff. Something's wrong with my sugar here. I'm sorry. Why is it beeping at me? All right, hi. All right, that's fine. Deal with that. Sure. All right, so it'll wait and then handle the session when two people join. So the first person, right, we accept the connection on the socket. Right, now we have player one. That's the socket connection here. And then it's just going to go log that information here. Here's who connected. Again, it's more interesting if it's actually on the network rather than local, but that's what we're dealing with right now, and that's okay. And then it goes and writes that, hey, here's the integer, you're player number one, right? That's the first thing we get. And then it waits for a second player to connect. The next person to connect to that port number is now player number two. We do the same thing. We log some information. We say, okay, you're player number two. So the client process, the first number they get, they know if they're player one or player two. and then it does another thread thing here. So that thread that is waiting and listening for connections will spawn another thread. They're like, okay, now go play the game. Right? Now that I have two players, go play the game. That's all this one does. So then the handle as a session here is the thing that's doing this bit here, playing their game essentially, right? That way you can launch multiple tic-tac-toe games here, so I can have dozens of clients if I wanted. Because tic-tac-toe is so fun, right? So we have the socket set up for the players, and then it deals with the game stuff here. We've got data input and output from the different players, right? To the player, from the player, or inputs and outputs. And then uh, it builds out its little tic-tac-toe grid, and then it runs, right? The run is the runnable bit here. So it goes and grabs those input streams, right? Makes the input streams, makes the output streams. So I've got ways to send data. And then player number one, it sends a one to tell them, okay, start. You're ready to go here. Then, as long as the game is being played, right, we're going to keep playing here. We go get the int row and the int column. So we can read two integers here. We're not dealing with strings and having to parse stuff and have trouble with that. So just read two integers and mark that row and column with the X. Then if the game's over, send a, hey, game over message, player one won, to the players, right? Send them the move and then break your loop. The game's over. Stop your loop here, right? If it didn't win, we see if it's a tie game, send them the draw message here, send the move to the player, and then break. Otherwise, we just tell, hey, player two, it's your turn, and then here's the move that happened. So the client is always looking for what happened. Either someone won, it was a draw, or it's time to keep playing, right? And then the move is sent so it can update the user interface to the client, right? So you can look at these different messages here. So like send move here says, okay, we write the row and write the column. It's not all that interesting actually, but it's, we've broken it up in this one small little step here. To send that row or column, right? What the move was, okay? Then player two gets a chance to move, right? We read the integer. Here's the row, here's the column player two picked. Do the same thing. If they won, we tell both players they won. Otherwise, keep going. Now, what's interesting here, because the game can't draw on player two's turn, we don't even need to check for it, right? Because player two is always an even move, and there's 9 spaces. So that's why there's no check for a draw here. You just won, or we just keep on playing here. So you save a little bit of time there, and this just keeps on looping forever. So that's the server code. Right? So we just start up a server, and it just uses the text log just to show what's happening. Again, kind of fancy. It doesn't really need the whole user interface. It'd be fine to just be a text-based log here, because it's not really doing anything other than giving us a text log, but that's okay. Right? It's our little text area. Kind of fun. And then the client side that goes and connects in here has some information, right? Because it needs to be able to go and draw all of this stuff here. So it's using JavaFX, but actually using like lines and ellipses, doing it the code first approach, which is fine, right? It doesn't use scene builder and it doesn't have a controller. It's just doing it all in main via code, but that's okay. So when we start, we build out a grid here so we know what the cells are. Sets up a border pane so we can have some information around here, sets the scene, and then it connects. Right? To connect, it says, okay, go make a socket to some particular host here, which in our case was localhost, right? Or you could put in someone else's number, and here's the port number. They picked 8,000 for the port, right? Pick a number here. And then here's your connection from the server, here's your connection to the server, right? Your input stream, your output stream, okay? And then launch the thread that goes and controls the game, right? This thread happens separately from the interface again. So then we go read what player are we, right? Remember the first thing that the server sends is your player number. You're either 1 or 2. Okay, you're player 1, you're player 2. If I'm player 1, right, which we're getting out of these constants here, that way we can send integers and they all have meanings, right, with nice names here. If I'm player 1, then I must be an X, the other person's an O, and then I'm going to, at some point, put those labels on the JavaFX screen somewhere, right, that run later. Then, okay, whenever we're ready to go, right? It tells us, it gives us an integer. Hey, it's time to play. What we just don't do anything with it. We just know that means it's time to play because we have to wait for the other player to connect here. Then once we know we're ready to go, all right, the other player's joined, let's go. Right? Or if we're player 2, then we know what's happening here. We're just waiting for player 1 to get the move. Right? Either one of those cases happen. Right? And then while we're going to keep playing here, right? If we're player 1, do the thing, send the move, get the input. If we're player 2, get the info first, then wait for the player to do something, and then send the move, right? Just the sequence is ever so slightly different here. So to send a move, right, we say, okay, let's write which row and which column we picked, right? Wait for the player's action. Where's that one function? Where's wait for player action? There we go. Did I miss it? I must have missed it. Wait for player action. Oh, I'm sorry, it's right here. Yep. It just waits, just sleeps, and just sits and sleeps and sits and sleeps and sits and sleeps and sits and sleeps. Um, Eventually, the player will do something, right? And the waiting will no longer be true. Right? This waiting variable here is going to change when the player does something, right? So one of the things we did in our where's the Java FX here, we said when you click on something here, you handle the mouse click. Once you've clicked here, then we're not waiting anymore, right? So 10 times a second is just did the player click something, did the player click something, did the player click something, because these happen on different threads is part of the problem here. So we have to click on the JavaFX thread, and it has to set something that has been clicked so that the other thread that's waiting, talking to the server, can know, oh, now I have to go do something here, right? So now we're no longer waiting here. It'll continue on, right? So that loop just runs forever when we wait for player, right? We said, hey, let's wait for the player action here. We're waiting for them to click, right? While waiting, it just sleeps. And eventually waiting gets set to false on a different thread. And this will stop. We put waiting back to true, but our function's done. Then the rest of the code can keep going, right? So that's our way of waiting so that once they've clicked, I can do something here, which will send the move and then get the info from the server, right? When I get the info from the server, let's go to definition, implementation here. I'm going to read the integer here for the status. If it's player 1, then I can say, okay, the player 1. If it's player 2, 1, then okay, player 2, 1. If it's a draw, okay, then we do the draw. Otherwise, okay, get the move, set it to my turn now. Right? So receiving the move, it's here's the row, here's the column, and we have to set the token, right, of the other person's token. I know what my move is, I just know what their token is. I'm going to go and set that token here. Right, so when I call set token, go to implementation, right, it just says, okay, here's my token, and then repaint. Repaint does this whole fancy thing to know which of our tokens are which here, and knows X's look like this, right? They draw a line here. O's look like this, they draw ellipses. So repaint just goes through and redraws the board for you, right? With lines or with ellipses. That's all. So it's some fancy math to figure out which one's which, right? So we got the server up and running, so I can run one client here. And then I get a tic-tac-toe. We're player 1 with token X, waiting for player 2 to join. Right? They have the spaces to put these sort of messages in here. And our server says, hey, someone connected from 127.0.0.1. That's our local host address here. We're not actually over the network. It's not all that interesting right now. Player 1 joins. So we're still waiting for player 2. So I'm going to come back and I can run this again now. I have a second client up and running here. Now this is player 2. Their token is O. We're waiting for player 1 to move. The server says, okay, started the thread, right? Player 2 joined, player 2's address. We started a separate thread for those two players to connect here. Now we're waiting for 2 players to join because you can have multiple sets of players at a time that our server's managing, right? You don't have to. It's okay to just have it do one session of 2 people or something like that. So then this player, right, at 10 times a second, it's sleeping and waiting to see if I clicked something. Right? Once I clicked one of these things here, right, it grabs, okay, I clicked with the mouse, right, and then it has to figure out where did I click, right? So when we get our user's action here, where's that one? Where'd it go? It's one of these ones here. Click, right? It was the mouse click. The cell, the handle mouse click, right, says every one of those cells, right, can handle the mouse click. So it knows which one was clicked on here. The cell handle mouse clicked, right? If I clicked it, if the token is blank and it's my turn, I can do something. So if it's not my turn, it just ignores it, right? So when player 2 clicks, it's ignoring it because it's not my turn, right? But when player 1 clicks, it's going to go, okay, set my token on that cell. Now it's no longer my turn. here's the row, here's the column that I picked, right? They come from the row and column of the cell, right? They made a cell that is a pane, so they put a bunch of these panes in here. So this way, if you do JavaX code first, it's kind of fun. You have a lot of control over these options here. Um, and then we set the label, and we're no longer waiting. We know what we've picked, right? So that information can be sent to the server later. So where should player one go? Which move? Right in the middle, you said? And this one gets updated right away, right? Because it's just waiting to get that response. Now it got the response. Now it's going to wait for the player. So every 10 times a second, it's just waiting and waiting and waiting. So where should we click for player two? Or I'll be player two. You guys be player one then. Where do you want to go for player one?
You already.
You didn't lose yet. Bottom left? Okay, sure. It doesn't really matter here, does it? So I need to make sure you are not going to win with a double win, right? So I need to force you to make a move. So I can move here, so you have to stop me. So you're going to stop me, so then I'll stop you. And now you can try and win, and then I'll block you. All right, so then I block you, and it's a tie game. Game is over, no winner. So as we're sending the data back and forth, right, the loop that's just waiting is waiting to get that information here, right? It works very well with a turn-based game, right? Real-time games, much different here. And trying to do that by hand is not anything I would recommend. Just go get Unity and use Unity, or go use Unreal. It's like, it knows how to do all that stuff automatically. Or go talk to Dr. Maxim and the game design program. They do cool stuff. This is how you can build a client-server process here behind the scenes, right? And notice it's not logging anything else. We're not logging every single move here. We just logged, okay, 2 people connected, they go play, right? You can log whatever you want here, right? But it's still running, managing the session. It's just not logging anything any further, right? So that makes sense. So you can start more than one client on your computer. If you've got client code, you can just right-click and run to run it again, to run another client here. So if you want to demo it just from one computer, that's perfectly fine. It might be a little trickier over the network. I don't know why the Wi-Fi wasn't connecting the way I expected it to, but we can just run multiple clients from here if that's what we want to do, right? And then to persist data in between, right, all we need to be doing is sending it to the database somewhere so that the server can access that information in the database, which is probably nice because if you're running on your laptop, I assume your laptop at some point will turn off, right? I don't know if that ever happens to you, but at some point my laptop turns off, right? So it's not always running. It's not like a cloud-based service that just is always out there. And that's what's nice with actual servers is usually they're on 24 hours a day, 365 days a year. They do need to reboot occasionally for maintenance and things like that, and so we need a way to persist at some point. But someone else's computer or cloud servers can run much longer than our laptops can run. We can deploy stuff out in the cloud and do other cool things with that eventually. But that is a Java FX based project here. So let's stop all of our clients here, stop our server. Very exciting. So the big piece, right, make sure anything you're doing that's updating a UI is done in this platform run later thing. Right? It's just, this will happen at some point, which is usually pretty quick. Right? It's not a slow, big laggy thing here, but it happens right on a separate thread because we want the UI stuff to happen separately than our processing threads because we don't want to block anything. That makes everybody sad if our UI just sits there and is waiting and not responsive, right? So that's what that lets us do here. So I've got the code, I've got references here. We just stole it right from Mr. Liang here, which is great. I'm glad he's still got that example out there for tic-tac-toe. Sorry, that's my insulin alert. Yes, stop. Thank you. Okay. Hi. Feeling okay? We've got Thanksgiving week. Take the week off if you want. Do a couple things, right? Maybe Monday, Tuesday, Wednesday. Don't do anything on Thanksgiving Day. Week after that, get together with your group. Don't let them tell you they don't have time. Right? They were supposed to have Thursday nights free. If you've gotten nothing from them in the next 2 weeks, right? You need to have been telling them, hey, if we don't get anything from you in the next 2 weeks, we're going to fire you from the team, right? Again, be open, communicate with people. There should not be surprises. If you're a terrible team member, people should be telling you you're a terrible team member, right? It's not going to come out of the blue, be like, I didn't know you thought I was terrible, because you've been telling them, hey, you haven't done anything for us, or you gave us crap, right? You gave me AI code garbage that doesn't work with my code, right? Like, communicate, right? Talk to people. And then in 3 weeks, then we'll do our presentations for finals. That should be a lot of fun. So it looks like a lot of people want to do like the little task list, which is fine. Like you connect in, you see your current tasks, you can add tasks, remove tasks, and you connect and you close, right? But if multiple people can get in at the time, as we're editing tasks, it should update, right? If you want to add like a refresh button, that's fine too, right? It doesn't necessarily have to live update. You can have a button that they click on to manually go look for updated tasks. That's okay, right? We're not looking for amazing, AAA quality applications here. We're doing a functional demo of a Java networked application. Okay. That's all it is here. So again, it's like a 50-hour project, right? Nothing super crazy is the goal, right? With 3 people working on it here, that's a dozen hours each, or 15-ish hours each, right? Not an incredible amount of work is sort of the goal here, but it should be something slightly significant. And it would be cool if you could show it off at some point. Like, hey, look, I had to learn a bunch of networking stuff to do this, and I built an application that does multi-threading, these sorts of things here. And if someone asks you in an interview, do you understand how multi-threading works? You'd be like, sort of, right? I don't know if anyone really is good at that sort of thing here, but um, some senior devs who do it all the time probably are. But you know, your answer probably is not, oh yeah, I can multi-thread anything, right? It's, oh yeah, we worked through it. We figured some of it out, right? And that's the goal, just to expose you to something new, add a new tool to your toolkit, give you something cool to talk about, and explore something different than C++ or Python or whatever you've done before, right? It's been a lot of fun. I talked to the grader. I've got to finish getting the midterms in for you, or start getting the midterms in for you. She's probably not supposed to grade those based on the geo contract language, and that's fine. So work on those. I think she said almost all the projects were scored. She was going back and forth with some questions. If you asked her and didn't like the answer, ask me. That's fine. I'm happy to take a look at things as well. But she's pretty cool. Um, and then syllabus quiz and pre-tests. Please get in the pre-tests at some point. I'm supposed to turn those in as part of our accreditation process. I didn't have them the first week though, so whatever, they can wait. But get those in at some point for me, and we can go from there. Okay. Awesome. It's been a lot of fun. I'm looking forward to seeing what you guys work on. If you get stuck on anything, let me know. Reach out. Always happy. It's probably pretty easy to just hop on a screen share anytime. Or Monday and Wednesday, I'm here before and after my morning classes or afternoon classes. You can always catch me then up in the CIS building as well. Just shoot me a message if you want to meet in person, or we can schedule something over Zoom lots of other times. Okay. All right. Thanks so much, and I'll see you in mid-December.